Hi, good morning, everyone. Thank you very much for joining us on this webinar. This would be our last structural, or rather STAAD webinar for the year. For some of you who are not familiar, we are Benca Process and Solutions Limited. We are based in Trinidad and Tobago, and we are the representatives for Bentley Systems. We're joined here this morning by Carlos Rincon, who is from Bentley Systems. Carlos is a structural engineer. He specializes in STAAD.Pro, Autopipe, Carlos, yeah? You know some Autopipe. And yes, so I will be handing over the session to Carlos. Feel free to put your questions in the chat, and we would allow an opportunity after the presentation for questions. So we're looking forward to those questions, and I'm now handing over to Carlos.
Perfect. Thanks, Wendy. Can I start, right?
Yes, yeah, sure, Carlos.
Perfect. This session will be recorded. You can forward after for your purpose regarding any structural requirement that you have. In general, we have information really important to remark about the stat line. As you know, probably most of you and the people that we see this presentation after, STAAD.Pro is our premium line structural workflow in our portfolio that allows to do analysis and design of structural systems, structural models in general, any kind of model that you can try to do using this kind of software. So the introduction of this presentation is about generalities, about a structural portfolio, a structural workflow. Remember that probably the principal focus that we have in Bentley is try to do a workflow regarding digital twin. Digital twin is a principal introduction that we always present and we always say before any, because this is the final focus, and no matter which product or which workflow or which infrastructure project we have, the final part is the digital twin. Digital twin try to find total interoperability. Total interoperability is our mission, is our vision, starting from structure, starting for piping, starting for offshore, starting for any kind of workflow. So finally, we will have a interoperability, total interoperability with this kind of project, multidisciplinary. So our Bentley mission is to provide innovative software and services for companies that do the design, build, and operate infrastructure, sustain the global economy and environment to improve the quality of life. Remarking, as always, this is a principal slide where we have approximately 400 applications for all infrastructure cycle. In this remark, we need to say that, for example, we have software in many fields of engineering, but the important is not exactly that we have 400 applications. The important is we have software in any kind of infrastructure project, for example, building, for example, roads, for example, water, and other. And that is not most important. The most important is we have interoperability between all. We can start, for example, in buildings and go to mining and go to power plants and go to nuclear power, etc. This is the most important part. presentation have focus in a structural portfolio. As you know, my name is Carlos Rincon and this is my email. I'm product sales engineer for Virtuosity and Bentley system. The agenda is digital twin introduction, structural portfolio, STAAD line, STAAD.Pro and STAAD.Pro Advanced, STAAD Foundation, and Interoperability. Regarding digital twins, digital twin is a digital representation that connect as possible all data coming from models, from analysis, from sensors, and from all as possible. Okay, as you see, it's a kind of representation, total representation. When there are people waiting in the lobby, just to telling you for admit to join this presentation. So digital twin is a general representation of all. What is the difference, main difference between digital twin and BIM? Remember that BIM is so important in our infrastructure projects now, but what is the main difference between BIM model and digital twin? Is the information data. BIM is just properties and geometry. It's a good step, it's a good evolution. But digital twin is one step more because we have the rest of the information. What kind of information? Reality information, sensors information, analytical information, stresses and forces. In a BIM model, we don't have that. So in digital twin, we have the rest of the information to complete the complete avatar of the infrastructure project. In general words, Bentley digital twins combine engineering data, reality data, internet and other raw data to complete the whole information as possible for a multidisciplinary infrastructure project. In structures, how to do digital twin with 4 software or with 4 software line. Analytical software like STAAD.Pro, translator software like Analytical Synchronizer. Analytical Synchronizer takes STAAD.Pro models and translate the model to other platforms. Which platforms? Structures and open buildings. That is BIM software. BIM software is the third part of digital twin. You see the difference, right? Digital twin included BIM. So this third step is BIM software. BIM software like ProStructure, BIM software like open buildings, but BIM software like Autodesk Revit or Tecla software also, and IFC models. So digital twin included analytical models, translator software, BIM software, and reality data. Reality data doing with any kind, but of course, we have more interoperability with our context capture that do reality models from mobile pictures or drones pictures, okay? So in general, this is the purpose of digital twin, to have all. Go to structural products. This is our structural products. The first one, or the main, is a structural work suite that including all connections. But this presentation will be more focused in STAAD, okay? This is our structural lines products. STAAD.Pro, STAAD.Pro Advanced, STAAD Foundation Advanced, RCDC, Steel Auto Drafter, Run Elements, Run Structural System, Run Concept, and Run Connection. This is our structural portfolio. We'll be more focused in STAAD line today. Starting with STAAD line. STAAD.Pro as the first one. It's the world's most widely used structural design and analysis software in the world. Why? Because we have more than 30 years in the market, and because it's a general software, so intuitive, and one of the easiest software in the world in the geometry part to do general analysis. What means exactly? Well, general analysis including physical modeler, analytical modeler, automatic load combinations, AT codes, wizard, section wizard, dynamic response spectrum, seismic static, and STAAD editor. We will go to STAAD.Pro for a while. Okay, I will open the software to show the general about STAAD.Pro. After we go a little for STAAD.Pro Advanced, and after we will go a little for STAAD Foundation Advanced also. So, talking about STAAD.Pro only, this is our general configuration that we have. If you have a license of STAAD.Pro standard, you have a kind of traffic light represent, and you select just STAAD.Pro only, where, well, basically in configure and license. In license, we select STAAD.Pro or STAAD.Pro Advanced. I will select STAAD.Pro Advanced to explain both stuff. I will open a new model, select the folder, always is important that, okay? Select folder, and this will be example 1. STAAD.Pro have 3 environments: analytical, physical, and building. Analytical, I will explain a little more, but I will talk about a physical modeler in the final part. You choose unit of your preference, and you create the model. What I would like to explain in these few minutes about STAAD.Pro in general. Well, for me, the 7 steps to do any kind of analysis in linear analysis. What is the 7 steps? We start with geometry. First step, geometry. First step, geometry. How to do geometry? Well, you can add a beam, okay? Or you can add a beam, you can add nodes, create a geometry starting from a node, for example, okay? Creating nodes and beams from scratch, okay? Imagine that you are create beams one, or copy and paste. What is copy and paste? It's just Control C and Control B. That's it. And you can create a geometry quickly. But I will do more quickly. I will delete these nodes. I will go to Structure Wizard. In a Structure Wizard, we have complete wizards already for bridges, for example, and you can edit. Imagine that you have, well, 50 feet, sorry. Select unit, they will change for meters. Okay. 50 meters. No, I will like 60. Okay. I will define different measures. Perfect. or different steps. No, I don't want 3, I would like 4. And this will change same time for bridges, warrant truss, other types, frame models, buildings. Okay, already we have the building. Okay, so this is a kind of very quickly way to do any kind of model, and we don't have exactly just buildings or bridges. We have surfaces, we have cooling tower. Okay, we have a spherical surface, and we can do a kind of vessels or just architectural stuff and export to STAAD.Pro in 1 second. But imagine for a while that I have, I don't know, a frame, for example. We have silo, and other types. Okay, but imagine for a while that we have a building. I will change a little stuff. Imagine that I have here, and that recognize if I change 12 meters, he divide through 3, 3, 2, 3, and 3, or if I put 16, he recognize, and we export to STAAD. So the first step, geometry, we have already. Second step, specifications. Specifications could be concrete and steel, of course, or any specification. Imagine for a while, just for a while, that we define our steel. Go to steel, and we choose one property. We are doing something fast. We are not doing detailing design, of course, but it's just to remark the steps. Second steps. Third step, support. The support, we go to specification and define, pinned, fixing, custom, or other. We are not explaining huge stuff about support, but usually for steel, we use pinned. Why? Well, I will explain in a general representation, okay? Of course, this is a other subject that we can talk. We can talk in other kind of webinar also. But the important is, depend of the support, we have base plate or bridge support for a steel structure. This support is not completely rigid. We have allowing a little, a kind of representation of the moment. So for that reason, and criteria in general, of course, we say that pinned most probably in a steel structure. When we have concrete, these support usually have moment restrictions. Why? Because it's embedded in the soil, a pile, a foundation, etc. So first step, geometry. Second, specification. Third, support. 4, loading. We define loading. For example, dead load. Imagine, right? Dead load. And in dead load, we put self-weight. For example, just for example. Live load, imagine, second one, and no more. No more for this example. Live load. 5-step automatic load combinations. We can check the tables of automatic load combinations, right? In automatic load combination, we have tables regarding many standards, and we can define more. We can create a new code. Imagine that you are in a country, I don't know, don't you have difference in the standard, not exactly AISC or other standard, no, and you create your code. But imagine that you know your code. Automatic load combination, go to the code, for example. In this case, I know that IBC table 232 is RFD combination. So I have the combination, 5-step. Geometry specification supports load and combination, 6 and 7. Analysis, click analysis, and that's it. And 2 more steps. This is not exactly a step, but it's important to do. Usually define the combination for the design. And finally, the design. The design have a pair of parameters that you need to analyze before and define and check code. That's it. This is a structure and 7 steps to do in STAAD.Pro. If I are complete, I can run. But apparently I'm missing the live load. We'll add 4 and second. Let me check something. 15 meters. Okay, I will add a roof live load, just a roof live load. One of my favorite commands, floor loads. Imagine that I put, I don't know, -2 kilonewton per meter square in 50 meters. One-way distribution to add. meters. Something. Perfect. Software recognize in 50 meters the distribution of the load. He do distribution per area. And if I define in 2 ways, he recognizes perfectly. But if I told the software in 1 way, he recognizes perfectly. So we are already, and I will do the analysis. This is the 7 steps to do any kind of analysis in STAAD.Pro. People ask me all the time, this is a software for what? It's a software for general structure. What means general structure? Everything. If I need to do a finite element model, I can do. If I need to do a bearing stone, I can do. If I need to do a chip, I can do, analyze statically. Of course, we don't have the criteria for maritime stuff, but we can do the analysis in a static position. If I need to do a building, of course, you can. If I need to do a musician instrument, you can do. In fact, I did. You can do anything. The thing is, the most important is define in your process the material, of course, because this is more related to the infrastructure project. We have very well defined steel, concrete, aluminum, and timber, but you can do your own material with different properties and analysis, and do the analysis with finding element method in this process. I will return to the presentation. So this is generality about STAAD.Pro. You can do any kind of model. It's quickly, it's easy, have more than 80 codes. You have a structure wizard and so on. And you can do a response spectrum in your country. or seismic static from US standard. You have physical model that we will talk in the final part, but physical model is really good stuff that are do evolution every year, approximate 3 to 4 times, and is incredible because the interoperability with BIM and of course with digital twin is really better. I will explain in the final part. iTwin Design Review is one of the news in STAAD.Pro. Is located in the right part, and the focus of the iTwin Design Review, including in STAAD, is to do in a close future complete digital twin. So far are just exporting the information of the structure to a review environment to communicate with the workflow team. And you can do comments and do modification to return to iTwin Design Review. Regarding important stuff in STAAD.Pro now to finish the part standard. A steel auto drafter. A steel auto drafter, when you do a steel model, for example, this model that we do with it. Imagine that you have a model. You go to workflow, a steel auto drafter. Okay. You select a position and do the configuration, and after you choose a plan elevation or section, click, and you have the drawing already. To export to CAD software, for example, AutoCAD or MicroStation or another. Okay. In fact, I will return for a while in my STAAD.Pro simple example. Okay. Go to Steel Auto Drafter. I did a simple model. Okay. I am selecting section or plan. Imagine. Select your scale. And that's it. You have the drawing. And you can export to MicroStation or save la ITXF. Okay, you can export to CAD software, and the scale is perfect. The profile is perfect, and including the bill of material. Okay, returning Steel Auto Drafter. Now we go to STAAD.Pro Advanced. In STAAD.Pro Advanced, we include this kind of analysis: no linear analysis, steady state, buckling, cable, pushover, and time history. Of course, we will not talk about all, but in general, some of the most required are pushover analysis. For example, that we do the define of this kind of no linear equivalent static procedure to predict many information important, but to predict the hinges about this kind of analysis. Okay. Other analysis that many people require to us is cable analysis to define cable in some types of structures. Time history, that is other kind of dynamic analysis that you need to introduce information about your time history representation, recording in any part of the world or your country or in your project. And you introduce the data, or you define the harmonic function or an external file representing some place to do the time history. And finally, RCDC, that means Advanced Design of Concrete. I will go to a while showing some parts of this kind of analysis. So we open STAAD separately. Open STAAD separately other 2 or 3 models to show, in general, this type of analysis. Small difference, of course, if you have doubts about this, of course, we can do separately meetings with more specific projects. But in general, I will show, for example, in the case of time history, I will open other STAAD separately. Depend on your system, of course, but the time history is located in definitions, and you have many ways to do. You need to create a new one and define a type and parameters. In the parameters, you have the option to do, for example, time versus force or time versus acceleration or other types, okay? For example, harmonic function or external file from other places. Remember that this is dynamic analysis for a specific behavior, and you define this particular procedure. In the case of cable analysis, depends of this type of structure. Of course, when you need a cable is a nonlinear analysis. Why is not a linear analysis? Because the axis area is not prismatic at all, because change with the tension and compression behavior in the cable properly. So it's one of the reasons. But this is a nonlinear analysis. Where is this analysis? Well, this analysis allocated in analysis and design and perform cable analysis. Okay, in perform cable analysis, we look at steps to do analysis, including nonlinear behavior in cable. What is the difference between a cable and not cable, or a cable or linear model? Well, the principal difference I will explain with editor. For people that not editor, it's a kind of command line in STAAD.Pro to represent quickly what is happening in the structure. For example, the geometry, this is the joint coordinates, okay? The load is below. Parameters is different. What is the main difference with linear and non-linear? Well, among others, the main difference is we use a perform analysis many times with a change command. Change means iterative command that do analysis, change, to do iterations to convert the result on the cable. Many examples about that, but important is to have a behavior and steps, perform change, and when you need to combine, the main difference is you will use different combine that is called repeat law. What is the main difference between repeat law and combination? Because sometimes apparently it's the same. The main difference is repeat is for non-linear procedure mostly, because repeat is about perform and change, perform and change, perform and change. This is the main difference, and you can define here the combinations with a factor. Will be the same, 1.4, 1.2, 1.6, but you use repeat to combine. The other example, pushover, for example. Pushover, you can, of course, use it more in steel structures, use it more in buildings, depend on of your focus. But in general, you define the parameters in definitions also. Remember, time history is located here, pushover is located here, and if I keep the FEMA procedure, I will try to predict the results regarding this kind of analysis and the position of the hinges. Okay, how to do? Well, I will share with you in general information separately about specific procedure, but the important is after define the parameters. Some of these parameters are regarding the standard. Okay, we go to post-processing, and we are not focused in the general results. We go to layouts, pushover, and beam results. In these beam results, we are predicting the position of the hinges. As you see, if we have in this first steps, we don't have the hinges, and appears after in the first floor in beams. Remember, for the regular procedure that we always say, being weak, column strong, the hinges need to appear before in beams. That's happening here. It's just an example, but it's the main purpose. After appears in the rest of the system. Returning to this, we finalize, remember, pushover, cable, time history, other, and we finalize with RCDC. RCDC is advanced design in STAAD.Pro, in concrete STAAD.Pro, that start with a workflow in a structure. You do concrete design, and you select pile cap, footing, column and wall, beam and slab, depend of your type of element. So with simple parameters, you have the all specific detail for concrete design in all these kind of element. It's quickly, it's easy, you can select any of these, and finally you have the drawings in general. Okay, same thing that we have in steel autodrafter, but now with concrete, and you can do to MicroStation, to other CAD software, and see the representation of this very specific detail. In summary, physical modeler, these standards, and many information that we are showing in the benefit of the STAAD. In STAAD Foundation Advanced, the third part that we would like to explain is one of the most powerful software in this area. Why? Because including almost kind of foundations known. What kind of foundation? For example, isolate foundations, combined foundations, math foundation, plant foundation, and so on. So this is a general workflow. You can start, for example, in STAAD and go to a STAAD foundation. This is one way. Or you can do standalone and check. An example, if you start in STAAD.Pro, you can export the loads and go to STAAD Foundation in one click. This is one of my favorite behavior because we save time. We are connecting STAAD.Pro and STAAD Foundation, STAAD.Pro and STAAD Foundation. So the STAAD Foundation receives the loads and we define the loads and create combination if we want. After we define a job, if the job could be isolate, combined, pile cap, and other. In this type, finally, we have the drawings and a very specific report. If we would like a pile cap, we can do, okay? If we would like a math foundation, as you see, we can do. And if we like other type, you can do. I will open for a while the STAAD Foundation, okay? I will go. In STAAD Foundation, we can check the foundation plan and define load combinations. This is some foundation in general, right? You can import from STAAD.Pro or you can start in STAAD.Pro and go to STAAD Foundation in Foundation Design, as I present a few seconds ago. But imagine that you have the reaction already. You can go to general load combinations and define, I would like service combination or ultimate combination. Why? Simple. The service combination is for service checking, like overturning, sliding, and other. The ultimate combination is for the design. And if you represent very well the combination, you can define the job after. In the case of isolate foundation, well, we have many examples that I showed a few seconds ago. I can repeat again. But if we want other, we create a setup, isolate, pile cap, math foundation, and other. Imagine that we have pile cap already. In parameters, that's the same for isolate, that's the same for combining, that's the same for other. You define parameter for concrete, for steel, reinforcement, for iteration, for soil, etc. But in pile cap, you have two ways to define the arrangement of pile cap, parametric or predefined. Here, for example, you can check your preference. No, I prefer an hexagon. I prefer bigger. Depends on what? Depend of your load. Depend of your load, you have a selection that would you at your type of behavior, at your type of load, you are selecting the best as possible. Could be simple, could be a more complex, could be more piles. After you check the loads in the pile and select the best as possible in this type. One of the checking, well, here we have apparently two. Saying we have this load in behavior, okay? After, of course, do the design, and when you have the design already, you have the schedule drawing or detailed drawing, depend on the footing, and calculation sheet. Detail all. This is in general because when you start in STAAD Foundation, you have 3 environments. General Foundation is the first one. I will save this. We'll wait for a while. We have 3 environments. General, General Foundation, Plan Foundation, and Toolkit. What is general? In general, it's environment that I showed before. We have pile cap, isolate, we combine, and we extract from STAAD.Pro. Plan Foundation is the second one. It's the second one that we present for Plan Foundation mostly, because when we are in Plan Foundation appears this kind of structs: visual footing, tanks footing, and other types. And the third one is Toolkit Mode. It's the third one. The first one, general. The second one, plan. And Toolkit is a really important mode that allow to us separately check-ins. For example, in this case, is other way to do a pile cap, but not combined with a STAAD.Pro, just standalone. When you go to edit, this is, if you see, it's a kind of spreadsheet. You put the load. For example, and you go to the rest of the step, okay? Finally, looking the design. Probably the same result if we have the same workflow, but in general, it's a separate way to do. I will open a new one, Toolkit Mode, and go to the STAAD.Pro for a while. Remembering interoperability, important stuff. Interoperability with the STAAD Foundation, as I told you, right? We export to STAAD.Pro and do pile cap or isolate foundation or mat foundation, etc. Interoperability with RAN connection. Remember, that means that we are in STAAD.Pro and we don't go to advanced concrete design, we go to connection design, assign connection, and go to the connection in the node. Quickly, fast, simple, 3 steps, including the equation of the standard AISC. And you play a little with the environment in this so easy software to check or change. Oh, I need a stiffener or not, or I need a ball or not. I can change the material or not. To refine this, and after to have the drawing with very, very well detailed. This is applicable to other kind of connection, okay? For braces, base plates, and so on. Analytical Synchronizer is a technology that allows to connect all of these. AutoPy, SACS, RAN, RCDC, IFC, Structure, Open Building, Revit, and Tecla. Cases are about interoperability. Okay, many cases we have. Many cases we have in interoperability. The first one is a combination or interoperability with piping using AutoPipe. For people that are interested for oil and gas projects or mining projects, we connect the structure with the piping in one click, in just 5 minutes, exporting the file from AutoPipe to STAAD, okay? And in very few steps, we have the design already. Second example, well, interoperability with SACS. We can do a jacket and go to STAAD and vice versa. Revit. We install a plugin. We install a plugin for free in Revit, okay, in this part, and we export the model in Revit, and we do just parameters in Revit, depending on the case, to export the model and go to STAAD. When we have the model exported with this translator, we open in STAAD in ISM import file or in Analytical Synchronizer. To explain a little better this, I will do a few steps in STAAD. For example, this is a physical modeler. In physical modeler, as you remember, we start in STAAD.Pro, but not go to analytical, we go to physical. It's very similar. We have a webinar that we can share with you just for physical modeler. The part of the geometry is very easy, and you can do the place with holes in very, very well way to do, and regions and so on. But imagine that we have already a model with properties, okay? For example, we have this model with properties very well represented, with specification, similar steps, because we have the model, or we have the specification, okay, that you assign in section. Now, I represent just the interoperability between this and BIM software or digital twin. So we go to iTwin services, okay? We select a repository. New, for example, repository 2. And we told the software push change. Here processing this translator software called Analytical Synchronizer to export to BIM software. Which software? Could be ProStructure, could be Open Buildings, could be Revit, or could be Tecla, for example. Imagine that we have this. This is a model that we have in BIM, right? Model from STAAD. We say update. Repository. We go now to ProStructures. Could be ProStructure, but could be Revit, could be Tecla, could be Open Buildings. This is a BIM software. ProStructure is a BIM software for structural detailing. Just to do an example, we open in a new file, import this type, new from repository, and open repository 2, that is this as I did, transformation. It tries to recognize what we have. PR processing. He recognized the properties, and that is the reason. This table is the reason because STAAD.Pro in physical model is better because the database is really more clean and big with many software, and of course with our workflow. The structure recognized, and we click OK, the material, and create the model. Okay, we start in STAAD.Pro. We do the model, and finally we have the structure variable import, and we can do many stuff like after, of course. And this is not the explanation today, but we can do structural object, connection design, short plate, and so on, structural detailing to do the drawings, variable fabricators, details. Okay, so I will return to the presentation. First, interoperability, AutoPy. Second, SACS. Third, Revit, Open Building, ProStructure, Tecla. Tecla example. This is a Tecla example, interoperability in STAAD, okay? ProStructures. I show, but this is a separate example in a video extract, okay? The same thing that I show. ProStructure, import from repository. We open, recognize the material. We have the structure, and we can assign base plate, end plate, and other times to do the fabricator drawings. Plaxis, this is our superstar geotechnical finite element software. It's not about Plaxis, this presentation, but it's important to know that we have connectivity with Plaxis. This is a geotechnical FEM software. So we start in STAAD, for example, okay? We do the same in physical model exporting, exactly the same we did with ProStructure. We export the model, okay? And after we go to Plaxis to import this model and put together with the soil. This interaction is so important for this kind of big project that we need the connectivity between both worlds, geotechnical and structure. Some successful cases, mostly interoperability cases. Just a slide to explain what is structural work suite. This explanation is not about structural work suite. This was more for STAAD.Pro and STAAD.Pro Advanced and STAAD Foundation Advanced, okay? And RCDC and Steel Auto Drafter, this line. But just to remark, structural work suite include all line STAAD and run line also in one suite. With so important benefits all together, okay? All workflow, connection design, piping, CAD behavior, interoperability beam, advanced analysis, all in one. And we will finish with the licensing types in Bentley system in handle with Benca process in this presentation. Our licensing types are this slide, no more. Perpetual word, that is a commonly perpetual permanent license. Is in many cases, our favorite license because in long time projects is more economic license because for one page you have a license forever. Okay, we have two separately types. Call it perpetual plus maintenance and perpetual only. In fact, but our favorite is Perpetual Plus Select Maintenance. It's not operation day in the license for long projects for big companies. Okay, for big companies that do a structure all time or oil and gas project all time, it's better to have this kind of perpetual types. Perpetual only is for other type of company, not including exactly the benefit of the maintenance. The third one is an annual license called CSS. And the fourth is virtuosity. This is a new type. In perpetual license, one or two, plus or not plus with select maintenance are with included select is floating license and included the updates. And interesting benefit that is calling portfolio balancing, that you can change one product for other equivalent product. Okay, it's just possible under select. Technical support and updates. CSS, an annual license. When you do a prepayment, whole prepayment for big project or many type of groups of products, 2 or 3 or 4 or 5 engineers is better for these types. And the cost is per month. It's possible to combine with other types and including this type of benefit. And the fourth type is virtuosity type. It's a new type in e-commerce format, okay, that including mostly products in Bentley, annual cost, low cost, and including training and same time, including Perpetual Plus Select and Virtuosity, including the Learn server that is a training in a web page that print a certificate per video that you saw. Like this, okay? For example, my certificate in STAAD, in RAN, or in other software, for all software you want. If you just have Perpetual Plus Select or Virtuosity, you have access to this kind of course for all software in Bentley. And this is an extract for the Virtuosity page and the Benca page that is including also our types, Perpetual, Virtuosity, and other, which is a new type with low cost in this kind of project. With this, we are finalizing. And of course, if you have questions, you can tell to Wendy, to the team, or you can email me, carlos.rincon@bentley.com. In general, represent important features about STAAD.Pro in general, STAAD.Pro Advanced in general, STAAD Foundation Advanced in general also, and licensing types and interoperability features. Can you hear me, Wendy?
Yes, I'm hearing you. Okay, so we can open up the forum now for any questions. If anyone have any questions or comments, please feel free to unmute and ask, or you can put your questions in the chat. Okay, Carlos, I actually have a question. In terms of designing a bridge inside of STAAD.
Right.
How good is STAAD at designing bridges?
Is really good, but we have a very good tool, a little better, not a little better. The real term is more focus for bridges. As you know, as I told, STAAD.Pro is a general software. You can do everything. You want a cup, you can do. You want a table, you can do. If you want a bridge, you can do. The thing is because some standard is not more focused, you need to put load by load separately, checking your as to standard or the standard that you are checking. But we have a very special software called OpenBridge that do for bridges do all automatically. So you have save more time. I have an experience before. Okay. For example, I did a bridge in steel, and I am a quick fast in STAAD.Pro, as you see, right? I do models and I can do a bridge. You have a wizard. I put load. I took 3 days, 4 days in analysis in a very specific steel bridge. What I use OpenBridge was for me 5 minutes. It's so different quickly because the commands are more focused in the wizard for bridges, because that included wizard for bridges just in the line part. But for OpenBridge, including all information on a substructure and superstructure at the same time together. In 5 minutes, you have all the model. In 5 minutes more or a little more minutes, you have all the loads, including NASTO standard. So you save time very well because it's more focused software. Of course, if a client say I need a software to do all type of structure, it's a STAAD.Pro for sure, because he wants, I don't know, buildings, towers, offshore structures, bridges, all. STAAD.Pro is better because you don't have limitations. But if your purpose, your focus is bridges, OpenBridge is an excellent solution.
Okay, we have a question from Jackie. What about the workflow for the design of a structural steel skid frame, including doing the lifting analysis?
Sorry, can you repeat?
What about the workflow for the design of a structural steel skid frame, including doing the lifting analysis?
Okay, it's possible because I told before, it's possible to do any type of analysis that you prepare. If you are doing a skid or lifting, you need to design a system that I did. Imagine indifferent, right? Not building. Imagine a skid or a frame, different frame. Okay, I will share for a while. Not to do, but to represent. Can you see my screen? Not now, right?
No.
Okay. Imagine that I have I can represent, for example, a floor. Just a simple example, but could be other kind of arrangement. You export to a STAAD and you define the load, and the main difference is you need to define the lifting points in the correct position. This is one of the important parts. Remember, the steps are 7. Geometry, the first one. The second, specification. Of course, it's not big deal. You define the specification of the beams. Supports, the most important part in lifting, because you define the support like lifting points. Usually defined like pinned, but if you consider that according to your criteria, it's not exactly pinned. It's have a spring you can do. But this is the third step and very important. You can do a geometry with lifting point using support, but you can also put a cables. That could be other way to do. Not always cable is so practical. It's more experimental sometimes. But you can change, of course, you can check, of course, the cable force and check with your catalogs and your lifting design. But if your focus, if your structure is better, not using cable. If your focus is the whole, and you need to be secure about all checkings, you put the cables. You do the performance change like I showed, and after you can create, if you want, a lifting model in FEM software, in FEM model. Okay, for example, you can do a model of the lifting iPad. Okay, for example, something like that. Imagine that just an example, right? This is not a bad eye, but imagine that we can do something like that with more specific shape for these third check. First one, structure with the 7 step. Second, cable, if you need to check. Third one, defining element model, if you need to check also.
Okay. Jackie, I hope that answered your question. You could always expand on it. Carlos, we have a question from Anil. Can you have direct export of Etabs to RAM connections?
No, it's not possible. I know a little Etabs. I'm not expert, but I know a little. I know that Etabs can recognize Excel spreadsheet, I think. You can go to RAM connection. Let me show a little. In a standalone way. In a standalone way, I show most is RAM connection with a STAAD, right? But this is a standalone way. In a standalone, we create a beam and edit the load. The load, for example, the load we edit here. This is a kind of general. And this could be, for example, that the people that do is export this or put the Etabs information here and try to do the standalone way. For that reason, STAAD.Pro interoperability is really superior in that part to Etabs or another software, for example, because we have internally with two reasons. The first one is because we do internally to not without export the loads. We have our loads already and go to connection design. That's it. Okay. But the second reason is because RAM connection is so powerful and have evolution every release. We have 4 releases per year, and we are increasing, as you see, the database. Database is increasing release per release. Okay, and the IAC checking is very detailed. The RAM connection thing is a really good thing that are trying to increase the powerful of this, and we have really expectations to new versions. The new versions comes very well. So for that reason, STAAD.Pro with RAM connection is really better to other options. In case of Etabs, you use more standalone way.
Okay, we have a next question from Jay. Since surfaces have been removed from more recent versions of STAAD, is there an option to perform RC shear wall design using plate meshing?
Okay, I will show something. For example, if you create a model, example 2, you put, okay, metric. Imagine we have simple stuff. I will put just simple workflow. 2 beams, 1 column. No, two columns, 1 beam. 2 columns, 1 beam. Remember, geometry, support, specification. I will assign properties. Support. Excuse me my fast, but I need to explain something. Support 1, 2, 3, loading. Load case, 1 load case, not spend more time. Self weight. Assign to view. Imagine that I define this like that low. Doesn't matter for this example. I will not define combinations. I will say analysis. And finally, concrete design for beam. I can do for column also, but just for beam. Okay, imagine that I did some concrete structure. When I do the analysis, in the past versions of STAAD, we use more the output to check this workflow. Now we go to advanced concrete design. Advanced concrete design I show in a video, but this is a simplest example just to represent something. The example 2, and we choose the standard. This ACI, M means metric, okay? And you can choose pile cap, footing, column and wall. And when we are talking about shear walls, this is the workflow. Put shear wall here, but together with columns, okay? So you do a model like I did, but with a shear wall, with a wall, and with column if you need, and go to column and wall. In my example, I will do with beam. In beam, you select the position, but if you go to column, it will recognize perfectly also. In that example, I will create for a beam, just to explain how is the general workflow, and to do more quick, more fast. But here, applicable for walls, applicable for columns, applicable for pile caps, you define the parameters, okay? Minimum rebar, maximum rebar, other parameters also. To do the design, in this case, called analysis load cases. This is from STAAD in general. Go here. assign the combination, and okay. General workflow. This is the design for one beam. Okay. We print with this a report. We print failure if we have failure. We print the design summary. And most important, elevation and sections for all, including cross section and cross beam. We have a beam that we did with the section, and the same thing is applicable with the shear wall. I will not do, but it's using RCDC, of course, and the main difference that we did some tests is you have a system like that, but you add in geometry a plate like this, and define also properties. The properties here, imagine, I don't know, 20 meters to do an example. And is in general, is the main difference. After you go to advanced redesign, we have in our official channel an example with shear wall where we can show to you. Probably it's better, in addition, select, for example, this plate and try to do a meshing, okay? Quadrilateral meshing could be, for example, 3 and 3 and 3, to do an example also. And separate. Why the meshing? Because you are connecting beams and wall. Of course, depend on your case. Maybe in your case are connecting one element or other not, depending on your case. You can also, if you consider, you can go to specification and release some connectivity points. Because if you consider this a shear wall, sometimes probably you have a force in one side and other not. You can release one of these 4 nodes in any plate. Okay, could be in one plate when or in other. Release one of the 6 degrees of freedom or any of you consider.
Okay. Any more questions from anyone? Okay, so thank you very much for joining us. We are basically looking at improving our webinars, and if you all have any suggestions on any topics you would like us to focus on, please feel free letting us know. Carlos, thank you very much for your support today. It was a very insightful. I'm seeing Jay has a question, Carlos. Is there a way to display results along a line in the output file?
Along a line. Are you mean a beam?
Jay, you can feel free to unmute if you like and dialogue with Carlos. Okay.
Well, if you want, I can show you something. Okay. Not exactly. I don't know exactly the question, but I will try to show a little about post-processing. Display results. Results is a subject that I'm not present so much today, but it's in post-processing, right? This is results. In results, we have all of these.
Carlos, he just said this is related to in-plane shear design.
in plane share. Okay, I will try to explain that what we have. Depending of the type of structure, of course. If we have a frame, this is the option that we have, okay? Nodes and beams, mostly. Regarding a plate, we have different behavior and result. If we have a non-linear, it's in layout, dynamic pushover, and a steady state and buckling. In the case of what I explained before, I will try. Not exactly the answer, but try to represent related. What we have in this type of process. Imagine that we have something like that. Go to post-processing, press OK. And one of the ways to do the plate stresses is here. And the plate stresses represent this type of information. I recommend for plate models, maximum absolute, usually. But we have more. We have von Mises, shear stresses, any type of stresses, top and bottom, combined and not combined, maximum, minimum. I recommend max absolute many times to represent something like that. Of course, if we have something more plain, we can do also the checking is the same, okay? And the interesting part of maximum absolute, usually the maximum absolute represent in color the maximum stress, and you can check with the maximum allowable stress in your material. Usually when this value is below to the allowable, we are okay, but it's not exactly science. In steel, it's probably more exact. In concrete, we have a parameters, but these are really good behavior about the stresses in general. The stresses could be in graphic, as you see. This is my favorite, and you have also in tables. Okay, in tables you can check here. If you are good checking the tables and numbers, you are checking shear, membrane, bending in the units that you need, for example, PSI or other, in your plate. This is my plate, this is my stresses. Shear and membrane, bending moment, and so on. If I want to compare with the color behavior, perfect, I can do. In mostly cases, this is a general way to check the results of the post-processing for plates and for beams also, but in beams stress when it's applicable to beam. Okay, aquí, here in beam, similar stuff. And we check the same. Go to post-process, result, in result, and all checking as possible using this important tool. In beams, for example, you have the moments and shear diagrams. In plate, we have, as you know, the behavior in color representation.
Okay, Carlos, we have another question. Can we export import between Tecla Structural Designer and STAAD.Pro programs?
Yes, perfectly. As I told before, we have interoperability with Revit and Tecla, and in a similar way with ProStructure and Open Buildings. This, if you remember, this is ProStructure. ProStructure is similar to Tecla. Okay, you import models like this, And after you design, for example, connection, base plate, then play another or other type of element like stairs or so on. Okay, so it's perfectly have perfectly interoperability.
Okay, great. Do we have any more questions? Please feel free to ask. Jay has another question. On the plates in the layout selection, there is the option result along line. That is what I was asking about. He was asking about the underplates in the layout selection.
Let me check.
Yeah. There's the option result along line.
Okay. Okay. This is about this question. I will support in my team to share more information about this. Okay, but it's included as you see. It's included as you see. As in theory, it's important to do a division of the representation and cut the part that we need during the line. Okay, I will not explain this occasion, but of course we will share with appropriate channels.
Yes, Jay, we can always address this offline with you. So we could arrange to have a session with you to go through these things. So yes, you're welcome. Any more questions? Comments? Okay, so Carlos, I think we could end off here. Thank you very much for your time. I know that we went over a bit. And again, feel free to contact us. Let us know maybe what topics you'd like us to focus on, very specific topics. And as well as feel free reaching out to us for any other additional information you might need. And we thank you very much for your support. And we look forward to doing more of these sessions with you. Carlos, thank you very much. It was a great presentation. And thank you for your time.
Thanks to all. Have a good day, and we'll be attentive to the next steps and following.
Okay, take care. Bye.